Video showing you guys how to tackle the problem of the two balls dropped from the same height, one ball dropped after the other one. I'm going to do this example using two cars, a red car and a blue car. They both start off with an initial velocity of 0. They both will have an acceleration, in this case, of 4 meters per second squared. They both will start at the same location or position, but the blue car will start moving 4 seconds after the red car. So this is just like the two balls being dropped. In the case of the two balls being dropped, they both start at the same height. They're both accelerated by the rate of gravity. It's just that one ball is dropped after the other one. Okay, so let me show you, because I know some people have asked about how to set up, like, the time data table, like, really quick, instead of inputting it like 0, 0.5 and then typing it all in. So if you want to do this really quick, so I want to go from 0 to 10 seconds. So I type in the first cell 0, and then I'm going to do my time changes by 0.5 seconds. So I type in the second cell, 0.5. Then I highlight both cells, and I go to the bottom right corner where there's a little square. Let me just do this again here. Grab that square, click and drag it, and then release it, and you see it repeats the calculation for me. So this ended up 11.5 seconds, so I'm just going to delete those last few cells. Okay. So the equation for the final velocity of the red car is the initial velocity plus the acceleration times the time change. Okay, so I already have this equation down here. I already wrote it. So I'm just going to copy what I have here for the equation for the cells that I'm going to be using. All right, I'm going to go over here, hit equals, go up to the formula bar. So I'm clicking up into the formula bar up here. Right-click and paste, and hit enter. Okay. Now let me discuss what this equation is doing. Okay, what my particular formula is doing. This $2 represents the initial velocity of the red car, so it's always going to go to whatever value I put in that cell right there. Then it's being added to, excuse me, $3, which is the acceleration of the red car, so it's always going to go to that cell, multiplied by parentheses E2, which is the final time, minus $5, which is the initial time for this car. Okay, so it's always going to return back to that cell, right? So now click and drag that, and there are my answers for that one. Now, there's a really quick and easy way to repeat this formula for the blue car. If I go back to the cell for the formula for the red car, the first cell, if I just go up to the formula bar and just highlight the values, don't highlight the equal sign. Right-click, copy, go back to the cell for the blue car, hit equals, go up to the formula bar and paste. Okay, now this is going to repeat the same calculations I have for the red car. So I need to change the cells to go to the values for the blue car. Well, the only difference here is where I see a B, I need to change those to C's. So I'm going to go the first B to a C, second B to a C, and this last B over here to a C, and hit enter. All right, it's -16. That's fine. All right, I'll explain that later. So now I'm going to click and drag this. Okay, 4 seconds later, you can see that that's when the blue car starts. Okay, it's at 0 velocity at 4 seconds, and then it starts moving. Okay, these negatives is just the result of the time difference ending up being negative. So what you could do here is, I know that from 0 seconds to 3.5, I know that the blue car is actually at rest. So I'm just going to type in a 0, and then I will click and drag that up to the starting point. Okay. But this is just a quick way to kind of get the formulas in there and get the information. Okay, now I want to plot this information. So I'm just going to highlight all of that, insert chart, and there it is. Okay. Now, if I look at the chart here, I'm going to edit this line just a little bit because it's a little hard to see. So I go to series, and you'll see what I mean in just a second. So interestingly, it gave the blue car a red value, so I'm going to fix that for a line. Change that, and I'm going to make it a little thicker if I can here. Well, that's the point size. Let's see if I can, there we go, line thickness. I'll make it thicker just so you can see the beginning part of it a little better. Now I want to fix the red car, so it's actually got a red line. Okay. All right, so when we look at this, we can see that the blue line right here representing the blue car, from 0 to 4 seconds, it's at rest, and then it starts to accelerate. Okay? These lines are parallel, so that means that the change or difference between the velocities is constant the rest of the trip. All right? So I can see that from this line right here. Okay, these two lines. Right, so you have to do a similar thing for the distance that the cars travel. You have to use an equation like this, but for displacement, okay? And then graph it to be able to answer your questions. All right, hopefully this video helps, and if you have any additional questions, just let me know.